Hello dear students. After a gap of few days, we are back again to this virtual classroom. Today we shall be discussing the chapter number 12 of your class 10 general science, and the chapter is electricity. So electricity is a very familiar word to us. We everybody know what electricity is. Without electricity, we even cannot think about the modern civilized world today. In our house, in industries, everywhere. Without electricity, the whole world will become handicapped. But do we exactly know when the concept of electricity began? It's a very difficult question, of course. In a prehistoric time, when the people they saw the thundering and lightning in the sky, they might have the concept of forced electricity in their mind, but they did not understand what is that exactly. Before Christ, 2750 years ago, in some very ancient manuscript, it is written that the fishermen in the river Nile, when they went for fishing, they got electric shock from the electric eels. And they were the people who experienced the electric shock. But later, 600 years BC, it was Thales who for the first time carried out certain experiments on electricity. However, that electricity today we call as statical electricity. But in our class 10 science, we will be dealing with the current electricity. But before that, let us come to know what exactly the word electricity means. Electricity is a set of physical phenomena associated with the presence and motion of a charged body. So when there is a charged body, maybe it is not moving or maybe it is moving. Maybe it is static or maybe it is in motion. This charged body always will show some phenomenon, and that phenomenon we call as electricity. So I have just mentioned this is thunders of Nile, 2750 BC. The people they got electric shock and they for the first time have experienced electricity. Then 600 years BC, Thales, he was the person who carried out certain experiments on static electricity. Let us go back to the example that you have learned in your lower classes. For example, the combing your hairs with a comb. If we comb our hairs, then what do we observe? We observe that the comb gets the power by which it can attract some small pieces of paper. The question was why? It is because of some static electric charge that developed in the comb. But the charges from the comb cannot move away. Means the charges which were produced inside the comb, they remain in the comb, they cannot move out. So that type of charges we call as statical electricity. But later, in 18th century, few scientists like Benjamin Franklin, Joseph Priestley, William Gilbert, and many more, they have carried out so many experiments. And after those experiments, the contribution of those scientists have become successful, and finally the charges started moving. And when the charges started moving from one place to another, then we get current electricity. So what is current electricity, or what is electric current therefore? This is the rate of flow of charge through a conductor is called as current or electric current. The rate of flow of charge through an electric conductor. It means that electric current will be conducted by a conductor. So what is a conductor? A conductor is the material through which electric current can pass. And insulators or bad conductors are those through which electric current cannot pass. So naturally a question will arise in our mind. Why a conductor can carry electric current through it? The answer to this question is that the conductors always have some free electrons inside them. And due to presence of those free electrons, they can conduct electricity, whereas the insulators never have those free electrons. And therefore the insulators are bad conductors. They cannot carry electric current. That is why I have written here the rate of flow of charge through a conductor. Now what is the rate of flow of charge? This is the number of charge passing through any cross section of a conductor in a given time. The rate is called as rate of flow of charge through a conductor. So that's, if we represent electric current with the symbol I, then I means electric current will be charge divided by time. That is the number of charge passing through the conductor divided by time taken to flow the charge. Symbolically, that is current is equal to charge by time. So we can represent it I is equal to Q by T, where Q is the charge and small t represents time. Now, if we take this diagram, we have represented this is a conductor, electric conductor. Through this conductor, some charges are flowing. We do not know what is the number of charges. Let's assume it to be Q, capital Q amount of charges are passing through this conductor. And from this end A to that end B, when the charges will flow, definitely the charges will take some time. And that time is supposed to be small t. Then what we will get? Number of charges passing through this conductor in a given time small t will give you the amount of current. That is, current is equal to charge divided by time. Through the conductor, when the charges will flow, you will get electric current. So that you have got I is equal to Q by T. So the SI unit of electric current therefore will be SI unit of charge divided by SI unit of time. SI unit of charge is what? Coulomb. Coulomb was a great scientist. In the respect of his name, this charge is always have a unit given SI unit, that is called as Coulomb. And time is represented with second. So SI unit of current is Coulomb per second. Coulomb per second is nowadays called as ampere. Andre Marie Ampere is another great scientist. So what is the SI unit of electric current? Unit of electric current is ampere. So if through this conductor 1 Coulomb charge, the amount of charge how much? 1 Coulomb charge passing through this conductor in 1 second, then you will get number of charge 1 Coulomb divided by time 1 second. So 1 by 1, this will be 1. So that will give you 1 ampere current. So what is 1 ampere electric current? When 1 Coulomb charge passes through any cross section of a conductor in 1 second, then the current passing through the conductor is 1 ampere. So that is 1 ampere is equal to 1 Coulomb divided by 1 second. But ampere is a big unit. Therefore, the ampere can be represented by small, that is like 1 milliampere. What is 1 milliampere? That is 1 by 1000 ampere. That is 1 milliampere is equal to 10 to the power minus 3 ampere. So electric current has both magnitude and direction. Magnitude because that is the amount, and direction, electric current always flows in a definite direction. So according to the concept that you have learned in your class 8 and 9, so definitely this should have been a vector quantity. So vector quantities are those which have both magnitude and direction. Therefore, electric current, since it has both magnitude and direction, it should have been a vector quantity. But electric current is neither considered as a scalar quantity nor as a vector quantity, but it is a pseudo vector. So what is pseudo vector? You will learn it in your class 11 standard. So when charges need to flow from one body to another through a conductor, then definitely you will require some condition. Without having those conditions, charges cannot flow from one body to another. That is to say that if this is a wire, through this wire, why the charges will move from this end to that end? If the charges need to move through this conductor from this end A to that end B, definitely you need to put some condition. What is that condition? The condition is you must apply potential difference. So before going to the potential difference, definitely we have to know what is potential or electric potential. So let us come to know these things. What is electric potential? Electric potential, which what we represent with V, capital V. So electric potential at a point in an electric field is the amount of work done in bringing a unit positive charge from infinity to that point within the electric field. So this is the definition of electric potential. Now let us explain what is electric potential exactly. Imagine this is capital Q is a unit positive charge. This is called as a source charge because it is placed at a point, and around this charge in a spherical region there is an electric field of this charge. Now this is the distance from the charge, what we are considering as infinite distance. And at infinite distance there is another positive charge which is called the test charge, and this is small q. Small q. Now where is small q? Small q is at infinity distance, and capital Q is a source charge present within this electric field. So we have to go back to the definition again. What is the definition says? This is electric potential at a point, means at this point A, electric potential at this point A, within this electric field will be the amount of work done in bringing a unit positive charge, from infinity to a point, say to this point P. Now if we have understood this diagram where this A is a source charge, unit positive charge, small q is a test charge present at infinity distance from this source charge. Now we need to bring the charge from infinity towards this source charge. Now if we need to bring it, definitely we have to apply a force. And if we apply a force, then the charge from infinite distance definitely will be carried to another point, say P. And at that time the charge will cover a distance. Since you are applying force on a charge at infinity, as a result of which the charge has covered some distance, so definitely you have done some amount of work. So what is the amount of work you have done? That is to say that this requires F into D amount of work done in moving the small q charge from infinity to a point within the electric field. Now this definition will give you one thing, that what is electric potential according to the definition. Electric potential is the amount of work done in bringing a unit positive charge. So electric potential mathematically is work done per charge. Work done per charge means work done divided by charge. Now if we represent electric potential as we have mentioned earlier, V, so instead of electric potential we can write V. So V is equal to work done means W divided by Q means the small q charge. So mathematically V is equal to W by Q. So V represents electric potential. So what is electric potential? Electric potential is the work done per charge means V is equal to W by Q. Here SI unit of electric potential is SI unit of work divided by SI unit of charge. SI unit of work is joule and SI unit of charge is coulomb. So SI unit of electric potential is joule per coulomb. Joule per coulomb. This joule per coulomb has given a new name, and that is called as volt. Alessandro Volta is a scientist, and to the respect of his name, this unit has been called as a volt. Volt. So what is volt? Volt is the SI unit of electric potential. And what is electric potential? Electric potential at a point within the electric field is the amount of work done in moving a unit positive charge from infinity distance to a particular point within the electric field. Now we have understood what is electric potential. Now similar to this electric potential, we have another important point. Whenever a unit test charge is placed in an electric field, unit test charge, imagine this is the unit charge, unit positive charge, which is called as a source charge, and this small q is a test charge. We are placing a unit test charge in an electric field, and then it will always experience a force emitted by the source charge. This is a unit positive charge, and this is also a positive charge. Between the two positive charges there will be a repulsion. There will be a repulsive force. Now the question is the amount of force experienced by the unit test charge. So how much force this small q charge is experiencing from this capital Q? The amount we have to measure. Now that amount of force experienced by the unit test charge emitted by the source charge will be called as electric field intensity. So electric field intensity therefore is the force experienced by a unit positive charge which is placed in an electric field. Now, if we represent this mathematically, that is electric field intensity, its symbol is capital E. So, field intensity is force divided by charge. Therefore, E is equal to F by Q. F by Q. E is equal to F by Q means electric field intensity E is force experienced by a unit positive charge within an electric field, and its SI unit is Newton per Coulomb. SI unit of force is Newton and SI unit of charge is Coulomb. So intensity has the SI unit called Newton per Coulomb. Remember, out of these two things we have got electric potential and electric field intensity. Out of this, electric potential is a scalar quantity because it has only magnitude, no direction. But electric field intensity means this one, it is a vector quantity because it has both the magnitude as well as direction. So hope you have understood something about this electricity. Today in this lesson we have discussed what is electricity, what is electric current, what is the mathematical representation of electric current, SI unit of electric current, what is ampere, and after that we have come to know what is electric, we have just come to know about the electric potential. Electric potential, that definition we have got the SI unit, we have got whether it is scalar or vector quantity, and finally we have come to know about the electric field intensity. In our next class we shall be discussing potential difference and electric circuit. Thank you.